The next question now we have is that write the structures of but2ene and 2-methyl-propene and show addition of HBr on both of them in the presence and absence of peroxide. Now we have but2ene first of all. Now this is a symmetrical alkene. If you add HBr in the presence of peroxide in this case, then the product formed will be 2-bromo-butane, and that is in accordance with anti-Markovnikov rule. Now basically this structure, that is but2ene, is a symmetrical alkene, and we have the condition for anti-Markovnikov rule as well as for Markovnikov rule that alkene should be asymmetrical. But in this case, though it has a symmetry, but still it can show reaction in accordance with anti-Markovnikov rule, because from either of the case possible, the product formed will always be a 2-bromo-butane. And next we have to do is we have to add HBr in the absence of peroxide. So in this case it will follow electrophilic addition reaction, and therefore product formed will be again 2-bromo-butane. Now in this case also, when pi electron cloud of the 2-butene attacks on the electrophile, that is H plus in HBr, it can have on either of the vinylic carbons, that is the electrophile can attack on either of the vinylic carbons, because the stability of the carbocation will be same in either of the cases. So therefore in the absence of peroxide also we will have one product, that is 2-bromo-butane. Now the next case we have in this question is again the same, that is addition of HBr in the presence and absence of peroxide. Now the reactant given is 2-methyl-propene. In this case, if peroxide is added along with the addition of HBr, then the product formed will be 1-bromo-2-methyl-propane, and this is again in accordance with anti-Markovnikov rule. Now in the absence of peroxide, alkene again follows electrophilic addition reaction. So therefore what will happen is the pi electron cloud of the alkene will attack on the electrophile, which is H plus in HBr, and the product formed will be CH3, C positive, CH3, and then again CH3. So now in this case the electrophile, that is H plus, will go on less substituted carbon, because the intermediate formed, that is carbocation, in that case will be tertiary, which is highly stable. So therefore now Br minus will attack on the tertiary carbocation carbon and forms 2-bromo-2-methyl-propane.